11.2 Steps involved in program execution process. Already, this concept I explained in a detailed manner in chapter number 5. Chapter number 5, the same concept I am repeating here and for the sake of integrity. Because by the time you do not know what are the functions, what is the purpose of functions and all that. Now already we discussed the functions. Now we learned about preprocessor. Preprocessor also plays a vital role in the compilation process. Now with reference to these two things, functions and preprocessor, you can better understand what is the program execution process. In 602 I have given. I don't want to repeat it because already I explained in a detailed manner. Just have a look. Now, first handwritten program. Handwritten program, we have to, if it is required, we have to properly edit it, type it and edit it. Then using text editor. Then after typing and editing, you get the C source program. Let us call it a test.c. Okay, this is our source program. Every C program, we save it with the extension C. Thereafter, now as soon as start compilation, preprocessor is first activated. Preprocessor is part and parcel of the compiler. Preprocessor first activates, it perform preprocessing. Already I briefed what is preprocessing. Then because of preprocessing, mainly you remember, then whatever comments are there, all the comments are removed and include statements are there. The include files are linked to the program, and any symbolic constants and macros are there. Those are replaced with the actual text. All these are part of the sum of the preprocessor directives. Now, the after preprocessing, complete preprocessing is over, then expanded source code. Source code is converted into expanded source code. Then, after preprocessing is over, the compiler is activated. Compiler performs its job. Only code what is required for the compiler, that is left over, and compiler perform its compilation process. As a result of compilation process, object code is created. Object code, a separate file. Then suppose your program is a test.obj. Object file is nothing but binary file. Whatever code you have written, the code is converted into binary form. That is object code. In the object code is a complete code which can be understood by the processor, but one part is missing because we are taking certain parts from the compiler, from the standard library. Because we are using standard library functions. Those functions, whatever code is created for those functions, should become part of our object code. Then only it will be complete. Then the linker. After object code is created, the linker links the standard library. As a result of that, that object code is converted into executable object code, simply called executable code. That file is a separate file, that is test.exe. Here, three stages we have to observe. The first one is whatever program you developed, the source program, test.c. And after compilation, pre-processing and compilation is over, test.obj, that is called object file. After linking is over, it is converted into test.exe, that is called that is executable code, and all the code in your program can be understood by all the instructions in your program can be understood by the processor, because it is in processor's language, in the binary. Then processor can understand all the instructions and instruct hardware in the required manner, and hardware implements that. As a result of that, program output is generated. This is the thing. Just you study this 602 and 603. I have given a flow chart also. Now, with this your mature knowledge, now you study, you can view it in a better fashion. Actually, in programming, one day you may study one concept, understand in one aspect. After you get some maturity, after studying advanced concept, you can view the same thing in different angle. That's why same concept I have explained in 5th chapter. Now we are in the 11th chapter. I hope that you can view same concept in a different view. Now once again you study that. Even if you understood the concept there also, once you study, it is a revision. Now here, in a different aspect, at every component, what is the input and what is the output? In a different angle, I want to show you the entire process of execution. Now you see, this is the component, first column component, second column, what input it is taking, what output it is generating. Now you see, you can get more clarity. Now, first, text editor. Now you can provide cut, paste, copy, like editing commands and all that. That is called editor. Now, once by using text editor, you typed your program and edit it properly. As a result of that, after typing and proper editing, a complete source program is ready. Let us name it as test.c. Test.c. Your source program is ready without any errors. Then, after that, you started compilation. Whenever you have given the commands for compilation, first preprocessor. Actually, it is part and parcel of the compiler only, and preprocessor is first activated. Preprocessor, what is the preprocessor's input? Preprocessor's input is source program. That is, according to our example, test.c. Test.c is the input of the preprocessor. Preprocessor, after preprocessing, expanded source code is developed. Expanded source code is developed. Next, after preprocessor, compiler. Compiler, after preprocessing is over, compiler is activated to perform its job. And compiler, what it takes, what is the input? Expanded source code is the input of the compiler. Then, expanded source code is translated or transformed by the compiler into binary language. Then, that a separate file is created that is called object code file. Object code file, object file, that is in this form. Test.c is transformed into test.obj object. Then this is a binary code. Thereafter, linker. The linker, actually in every program we call several standard library functions. Then linker links up the required library to our program. Then those functions are in compiled form, not in source form. Those will become part of our object code. So linker takes object code and links up or incorporate standard library functions into that, whatever we called. Then, as a result of that, executable code is created, that is test.exe, a separate file. Now we see first test.c source file, thereafter intermediate file test.obj, final file test.exe. This is completely in binary format, and the processor can understand. It is the mother tongue of the processor. So, processor's input is test.exe, that is executable object code, or simply called as executable file. Then it understands everything and instructs the hardware, and the hardware generates the output. So this one gives you better clarity on this concept. Now, after studying these 2 pages, now study this table and understand entire program execution process. In this context, I would like to explain one allied concept. Actually, earlier you couldn't understand that. Actually, in the first chapter, the special focus I have given this, but at that time you couldn't understand this. That's why I am explaining this concept here. That is standard library and allied directories. Now, when you write user defined functions, then you are able to find there are three components. First one is function prototype, function call, and function definition. Whenever you write a user defined function, you can find the three components. Function prototype is nothing but declaration of the function call and function definition. As far as standard library is concerned, where are these three parts? That may be your doubt. So, user defined functions are defined by the users. Users means programmers. We define. And standard library functions were developed by the developers of the C language. Those are also human beings. So, they must follow the same procedure. There is no special procedure for that. Instead of by the programmer, those are developed by standard library functions were developed by the developers. So, these three components should present. Now, our question is where these are stored. Where function prototype, all standard library for prototypes are in include directory, a directory name include. Its a directory name is include directory. In the .h files, these are called header files. All prototypes are stored in include directory with a .h extension. And function calls. As far as function calls are concerned, we are calling. Now, if you are using printf, what is that? It is nothing but a function call. Calling printf function, scanf, you are calling square root, you are calling pow. So, function call should be part of our program. We are calling whatever function is required. And function definition. Function definitions are in lib directory, lib directory, and all these are with the lib extension. All these files are with the lib extension. These points you must learn. And because somebody may ask you, then you should know about this. You should know about this. Here, for standard library functions also, three parts are there. One is function prototype, second one is function call, and third one is function definition. All function prototypes are stored in include directory with .h extension file, and all function calls we make, whatever function we require, standard library function we require in a program, we call that. You know that. Now you are calling this square root 1, 2, 3. This is a function call, that it is part of our program. Whatever functions we require, we call. Function definitions. Function definitions are with .lib in a .lib file. Those are stored in lib directory. This basic information you should have.